What's happening, dogs? Mr. Allen here with some radical simplifications here. It's going to be a radical time, bro. All right, but I'm going to do this by taking out perfect squares. So some people like to go through prime factorization with a factor tree, a bunch of 2s, 3s, 5s. I'm going to still use, a little factor tree action, but I'm looking for perfect squares. So 80 right here. Can I divide this thing by, let's see here. We got perfect squares are 4, 9, 16, 25, 36, so on and so forth. I can divide 80 by 4, I'd get 20. Maybe I can go bigger. Can't divide it by 9, but I can divide it by 16, and what am I left with? I'm left with 5. 16 times 5 is 80. Okay, so I've broken it apart to that. What's the square root of 16? It is 4. The square root of 5 is left over because I cannot find a perfect square out of 5. That's it, we're done. We could have done so with a bunch of 2s, circle pairs and all that stuff, but that's a clean look right there, man. A lot less work if you can find your perfect squares, okay? Let's try with the 45. So not divisible by 4. How about 9? Yes, it's divisible by 9, and I'm left with 5. Okay, so we got 9, we got 5. Square root of 9 is 3. 5 stays over. Boom. All right, it's not always going to be a 5. Okay, there might be a couple others in there. Poor planning. Anyways, all right. Next one here. Square root of 8, square root of 20. Now, you could put these things together first. That's cool. You could do that. You could break them apart individually. It's really up to you. I'm going to go with keeping numbers a little bit smaller, I guess. And let's break this apart to 4 and 2. So that would give me square root of 4 is 2 root 2. This one here would be 4 and 5. Square root of 4 is 2 square root 5. So that's all multiplied together. 2 times 2 gives me 4. Root 2 times root 5 gives me root 10. There's the potential for this one to break apart again doing this method. But square root of 10, I can't divide it by 4. Can't divide it by 9. We're bigger than that. That's it. We're done. Awesome. Cool. All right. Uno más. 40. I can divide 40 by 4, and I'm left with 10. I can't divide it by 9, 16, 30. Nope. It's 4. Okay. So 4 and 10. So we're going to have the square root of 4 is 2. Square root 10. This one here. Let's see here. I can divide it by 4, not 9. 16 would work. 16 times 3 gives me 48. So we'll have 4. Square root of 16 is 4. Root 3 left over. And now I can put this stuff together with multiplication. 4 times 2 is 8. 10 times 3 is 30. Can I break apart 30? It's not divisible by 4. Not 9. Not 16. 25. 36. Nope. That's it. We are done. Cool. So if you're doing non-calculator, you probably have to do this because 40 times 48, I'm not going to do that in my head and then try and break it apart. So you're probably going to go the route of just keeping things separate. Definitely a good non-calculator problem. But anyways, there we go. Simplifying rational expressions by taking out perfect squares rather than doing the factor trees with prime factors. I like this a little bit better, but to each their own. Peace.